Good morning. We're going to get ready to get started for our session today. So first of all, welcome to QGIS New York, getting started with QGIS. My name is Mickey Dietrich, and I work for the New York State Tug Hill Commission. Over the past several years, the Commission has been moving to QGIS for our desktop application, PostGIS for our online database, and GS Cloud for our online map viewer and mobile data collecting. This past year, a group of us from different organizations across New York State got together to put on a QGIS conference here in New York. Our original group consisted of Keith Jenkins from Cornell University, Elena Millette from the New York State Tug Hill Commission, Frank Donnelly from City University of New York, Rutgers College, and myself. Unfortunately, we had to cancel that conference given the COVID-19 situation, which we hope all of you are safe and healthy. In the meantime, we were getting questions from people on how to do certain things in QGIS. As some have had to work from home, we decided to go ahead and put together this training webinar to hopefully help answer some of those questions. Today, you'll be getting some basics in QGIS from a variety of different presenters we lined up, which I believe you can see their names listed in the agenda posted to the screen. We will be taking questions throughout. Please post them in the question and answer section, which you should see a button on your screen to do so. I believe Keith is going to test that just to put a quick question out to the group there. After all presenters have gone, we will again take more questions, and if there's something that was not covered, feel free to post those questions at that time. Also, any of us, I'm sure, would be happy to help any of you at a later time should you need assistance. We hope this training you'll find helpful. With that, I'll turn it over to our first presenter, Elena Millette, who will be doing her presentation on bring basic data into QGIS. Take it away, Elena.
All right, good morning, everybody. My name is Elena Millette. I work for the New York State Tug Hill Commission as a planner. I've been working with GIS for 8 years and QGIS for 5 years. So as Mickey said, I'm going to kick us off with an intro on how to add data to QGIS. Probably the most basic thing you'll need to know, and something everybody does pretty much every time they open up QGIS. So let's start with vector data. There are 3 ways that I want to show you guys how to add data. My personal favorite is the browser panel. So as you can see here, I've got QGIS open, I've got my layers panel, but I'm not seeing my browser panel. So what I need to do is right click up here in the area that has all of my tools and find browser panel. You can also find this in view, panels, and browser panel. So once I have that active, I connect that to my layers so I can see, switch back and forth easily and seamlessly between the two. So you'll see a list of folders. Home is probably where you'll have your files stored and your data stored. All you have to do is find the folder that you use most frequently for your data, and you can add that as a favorite. So if I go up here, you can see I've already made a favorite for the specific session. So if I go to my vector, I'm going to find my first layer that I want to add, make sure it's going to go in the correct area in my layers panel, and then simply drag and drop. So I got to make sure that's checked so that we can see it. So now you can see I'm looking at cities and towns. And another option you have is to locate the same folder in your computer's folder structure. So I have it in my documents in a database titled Tug Hill Commission and QGIS New York 2020. So if I go to the vector folder, you can see this is where the cities and towns layer was that I just added. But now I'm going to add counties. So you can see here there's different files that are associated with one specific shapefile. What I want is the file that has the feature geometry, which is the SHP file. So if I find that, typically it has the largest size, which is another indicator to know that's the right one. I drag and drop. So now if I zoom out a little bit, you can see I'm looking at Tompkins County. So a third way to add data is this tool up here called Add Vector Layer. So if I go to that, I click on File, and I'm going to follow the same steps. I'm going to go to my folder that says Vector for me, and find the next file I want to add, which is my lakes. So if I find my SHP file, I open that, add, and now you can see I've got my lakes file I've got my counties file, and I've got my cities and towns. So if you want to add a geodatabase, you can use the same tool, add vector layer, but this time go to the source type directory and find open file GDB. There, I'm going to navigate to the folder that has the geodatabase. In this case, I'm using the New York State DOT highway inventory from 2018, and you can see the folder ends in GDB for geodatabase. I'm going to click on that, select the folder, add, and close. And now you can see I've got my geodatabase visualized in my map space. So now that it's pretty similar when we're working with raster data. You can go back to your browser, find the raster data that you want to include. I'm going to add the land use land cover from the National Land Cover data set for 2016 and look for your image file, drag and drop. Now there's also a tool just like the vector, but specifically for, all right, turning off my timer, specifically for raster data. And so up here you see add raster layer, find the file that you want to include. I'm going to do a digital elevation model in Tompkins County. I'll just pick my first one here, open, add, and close. And now you can see I've got my raster layers in there as well. And of course, you can change the styles for your layers in QGIS just as in any other GIS so that they're more visually aesthetic. Okay, that's it from my presentation. I'm going to pass on the torch.
Okay, thank you, Elena. My name is Keith Jenkins. I'm the GIS librarian at Cornell University, and I'm going to be talking today about projections, plugins, and basemaps in QGIS. Before I begin, I just want to cover a little bit of terminology. So the term CRS means Coordinate Reference System. So basically your projection of the data that you're working with. EPSG is a registry that assigns unique number IDs to each coordinate reference system. So here are some examples. You may see some familiar coordinate systems from upstate New York here. And one thing to point out is that rather than having a long string of text that varies maybe just by the units like feet or meters or by the datum, there's a unique number that refers to that. So it's kind of a nice shorthand for referring to a very specific coordinate system. So I'm going to open up QGIS and I'm going to start by loading in some county data. And one thing you may notice, I'm just dragging over the SHP. And you may see this pop up. This happened, started in a couple versions of QGIS ago, based on some underlying changes to Proj, which handles all the coordinate conversions for QGIS. So this dialog is basically asking us if we want to pick a very specific transformation from one datum to another, one coordinate system to another. I think most users would be happy to accept the default and just click OK. You can also click this Make Default and it won't ask you about that particular combination of coordinate systems. But if you do want to pick a specific one, feel free to look through the list and use your expertise there. If you get tired of seeing those dialogues completely, you can go to the settings, and under options, there is a CRS tab, and you can uncheck this box to ask for datum transformations. So here we are looking at the United States. And I know there's a little bit of lag on the video, at least there seems to be here. So we can see the United States has this nice straight edge with Canada, and it's stretched out east to west because we're using a latitude longitude coordinate system. If we want to verify what system is being used, we can look at our properties of the layer. And in the very first tab, the information tab, there is a section here that says what the CRS is. Another way to verify it would be to just hover over the layer name and there'll be a pop-up that says the EPSG number, as well as the location where your file is located. Now the map project in QGIS is typically uses the first data set CRS that it sees. And in this case, I only have one data set in here. So down the bottom right, it says EPSG 4269. And if I click that, I can change the project coordinate system. This is the standard dialog for selecting coordinate systems. Let me just make this a little bit bigger. And you can search in here. The search is pretty quick. I'll look for an Albers coordinate system. And if I've used recent coordinate systems that match, I'd see them up here. But in this middle section, there's a long list of Albers coordinate systems. I'm going to scroll to the bottom and pick USA contiguous area. And there's this nice preview of where this coordinate system is valid and intended to be used, which really helps if you accidentally pick South America and you can see, no, that's not the one I want. So I'm going to pick the USA contiguous, and it immediately starts converting your data on the fly to match that system. And we now have what I call the smiling states projection, the nice curve. I'm going to zoom into New York State up here. The next thing I'm going to do is load in some tree points, which is a shapefile. And one thing I wanted to show you is that there's no PRJ file for this shapefile, so the projection is undefined, which means that when I add this over, first of all, I'll notice that I don't see any points showing up in New York State where they should be. And in the list of layers, there's a question mark. And if I hover over that, it says that this layer has no coordinate reference system set. So I can define it. So the person who sent me this data, who may be on this call, thank you very much, told me that this is in WGS 84 UTM coordinates, 18 north. So I'm going to go to set CRS, set layer CRS. And here I have that similar CRS selector. I'm going to search for 18N, which is a quick way to get to the UTM zones, and find the one down here for WGS 84, and I can see it covers the strip that goes through New York State. And once I do that, now my points are showing up here in Tompkins County, where the data is located. So one thing to point out is that when I assign that projection over here in the layers, it's only doing that within the context of this project. So if I want to, I cannot get to my processing menu. There we are. I'm going to go to the processing toolbar and just do a quick search for projection. And there are several projection tools. If I use assign projection, that would save a copy of the data set with the projection defined. However, if I'm using a shapefile, I can use define shapefile projection. And what this does is it just writes out that PRJ that was missing. So if I run that and then take a look at my directory, here we can see that it has added the PRJ file just this minute. It did not modify the rest of the shapefile. And the last tool here that I wanted to point out is reproject layer. So if your data is already defined, if you want to change it to, say, state plane coordinate system, do not use the set layer CRS. So this only defines how the data already is, not what you want it to be. So if you want to change the projection, assuming that it's already correct, you want to run this reproject layer tool, which will create a new copy of the data set in the new projection. So that's an important thing to point out. Now, it'd be really nice if we could use a base map to see how well these points align with a base map from, say, like Google Maps or Bing or something like that, or some aerial imagery. We're going to use a plugin called Quick Map Services, and adding plugins is pretty simple in QGIS. I'm going to go to the Plugins menu, Manage and Install Plugins. And there's a long list of over 500 plugins, so you could browse that list if you like. You can also search. If you know the name of the plugin, you can search for it by name, but you can also search for a term that might be in the description. So I search for basemaps, and here I can see the Quick Map Services. I'll install the plugin. This usually only takes a few seconds. It's going off to the official QGIS plugin repository and fetching the files it needs. And in just a moment here, it'll be done. Each plugin is a little bit different. Sometimes a tool is added to the toolbar. In this case, there is a web menu item now, Quick Map Services. Initially, you'll see a relatively short list of things, but if you go to the settings the first time you install it, if you go to More Services and click Get Contributed Pack, this will fetch definitions for all those other servers like Bing and Google and even Esri and a lot of OpenStreetMap-based base maps. So now when I look at my Quick Map Services, I can see this very long list. I'm going to open up the Bing map. And one thing you may notice is that things are aligning quite nicely. You'll also notice that some of these labels are at an angle. That's because of our Albers projection. So QGIS is bringing in those map tiles and then reprojecting them to fit our project CRS. Sometimes that can slow things down. So if you want to speed things up a little bit, you can go to your list of layers and say, let's use the project or set the project CRS from this layer, from the Bing maps. So that'll switch it to the web Mercator, so it doesn't have to do the extra work of reprojecting those. And then sometimes if the font size is a little off, you could also zoom to native resolution, which in this case snaps to the nearest zoom level for that base map. So there are a lot of other base maps here, including satellite images like this one from Bing that looks like this. And here I can see this leaf on imagery. The problem with some of these base maps is that we don't know what the vintage of the imagery is. So it could be from last year, it could have been from 5 years ago, we don't know. And that's where I want to show you the New York State Orthoimagery Web Services, and other states have this as well. I know we have some folks from Massachusetts joining us today. If you Google those words, you'll come across this page on the New York State website. And there's a lot of details about their web services, but the key thing here is that they have a WMS service. So that's web mapping service. And I'm just going to grab the URL and copy that. And we can use that to access that imagery on the fly. So I'm going to go to the Add Data, the Data Source Manager, and say that I want to add WMS. And I'm going to create a new connection here. I'll give it a name like NYS Orthos, and just paste in that URL. I'm going to leave everything else as is, click OK. And when I connect to that, I can see that there's several different years available. I believe 2018 was when Tompkins County was last flown, and I'm going to add that. It should be adding. There we go. So here we have this nice imagery with the beautiful April leaf off imagery, so we can see these nice tree shadows, and we could use that to adjust our points. So I'm going to pass it over now to Frank.
Hello, everybody. My name is Frank Donnelly. I'm the geospatial data librarian at Baruch College, City University of New York. And hopefully you can see my screen okay there. What I'm going to show you is how you can take an attribute table, so some census data that's stored in an Excel spreadsheet, add that to a project, and then join that to a boundary file for the geographies that are in the sheet so that you could actually map the data that's in your Excel sheet. So I have a project here that's ready to go. These are the municipalities within Tompkins County. This is a file that I downloaded from the US Census Bureau's Tiger Shapefile page. And as Keith demonstrated, I also have a WMS layer in the background that I've already added here. So this is my shapefile for the Tompkins County's municipalities. If I right-click on the layer, I can open up the attribute table. And I can see for most shapefiles that we download, we're not going to have a heck of a lot of attributes in there, but if we want to map anything, we have to go out and get them from somewhere else. The important thing here is that I have a unique ID code that identifies every one of my municipalities. That's the column that I'm going to use to join to the spreadsheet that I have. So let me close this, and I'm going to hop out of QGIS for just a second, so that I can show you the Excel file that I have. So this is some census data that I downloaded from the American Community Survey. And I have, you can see here, I have rows that represent each of the municipalities and then columns of attributes. Basically, if you're familiar with doing this, if any of you have used ArcGIS, in order to join a table to a shapefile, you have to have a really tight data table where every row represents your geography, every column represents an attribute, and it has to be pretty tight and be just data. So you can't have formulas, you can't have footnotes, you can't have summary totals. For example, when I downloaded this originally from the Census Bureau, the data looked like this. So I had 2 column headers, I had really long names. If you do things like this and you try and bring your file in there to join it, it's just not going to work. It has to be very tight and clean and looking just like this. This is an Excel file, but you can use the new or old Excel version. You can use the open document format. You can also use CSV files. All right, let me flip back to QGIS. In order to get an Excel sheet in here, you can do a couple of things. You can go to the browser panel like Elena demonstrated at the beginning. Or up here, we have this thing that looks like a little deck of cards. That's the Open Data Source Manager button. And in order to add a spreadsheet, you basically pretend that it's a vector file. So I'll have vector highlighted here, ... And then I'll browse through my folders, select the spreadsheet that I want and say open, and then say add. If your spreadsheet has multiple worksheets in it, like mine had 3, you'll be prompted to specify which sheet that you want. So I'm going to take that one, and then that's added it to my layers panel over here. Nothing draws because this is just a spreadsheet. It doesn't have any geometry. But if I select the sheet and open up the attribute table, if life is good, I should see all of the attributes that I saw out there in Excel should be here in this sheet. And I have a GeoID column, which is the same as the other. If you download shapefiles from the Census Bureau and also data from the Census Bureau, you should be in luck. And they should both the data table and the shapefile should share the same ID code. To do the join, you select the shapefile that you want to, or your geo package that you want to join your table to. I'll right-click it and go to the properties at the bottom. And this opens up all sorts of different layer properties for that individual layer. And there's a specific tab here for joins. So I'll select the joins, and there's a little green plus symbol at the bottom for adding a join. The join layer, this is the table that we're going to join to the shapefile. The join field, this is the unique ID code that's in that data table rather. The target field is the unique ID code in the shapefile. The names don't have to be the same, but each column should contain the same identifier so that they match. Down here, if you didn't want to bring in every single column in your table, you have the ability just to choose the ones that you want to bring in. And then at the bottom, this custom field name prefix, this is kind of a little gotcha. I usually come in here and delete this. It will prevent QGIS from appending this to the front of the columns, because if you do that, it could actually make the column names too long and it can get funky. So if you have that set up like that, we can say OK, and OK one more time. And just to make sure that this really worked, now if we select the Tompkins shapefile and we open up its attribute table, we should see all the attributes from the original shapefile plus all of the columns that were in the data table. Now just to take this to the final step, if we want to map the data that's now in that shapefile, I could select Tompkins County shapefile and go to the Properties menu. And this time I'll go to the Symbology tab. And instead of showing everything like the same symbol, I can show them as graduated colors. And here we choose the specific column that we want to map. Like I said, this is all data from the recent American Community Survey. This is some information about the median value of houses. So I can select the column that I want there, classify the data. Since we only have 10 municipalities, 5 classes is a little much, so I'll just drop that down to 3. And then you can also change how the data is classified. These are all the standard classification schemes. Natural breaks looks for gaps or clusters of data, so we'll try that. You can hit apply, and then voila, there's our thematic map of census data, taking our boring spreadsheet data and now making it spatial and getting a map. If we save this project, the project will remember that these things are joined together, and then we'll open it again and it'll be there. If we want to use the shapefile with the joined data in another project, all we have to do is right-click, export, and then save the features over again. And then saving them in a new file, that spreadsheet will be permanently fused to the new shapefile so that its attributes will be part of the new shapefile. That's a whirlwind tour of table joins and thematic mapping. And with that, I'll turn it back over to our moderator.
All right, so next up is Ryan Lennon from Baruch College as well, who will talk about print layouts.
Great, thanks, Keith. My name is Ryan Lennon. I am a GIS Data Services Assistant. I work with Frank at Baruch College. Today, I'll be going over print layouts in QGIS. And so using the print composer in QGIS, you can output your map as an image file. And this is how you can create prints using your data that you can then embed in documents or use however you want. And so you should be able to see my screen now. I have a map here that is all schools in New York City. And so you can see I have public schools, private schools, and a few layers that are not turned on. And so if I want to make a map out of this data that I can export, basically what I have to do is choose the print composer up here. It's the fourth icon from the left in the top toolbar. It looks like a piece of paper with a ruler over it. And so when I click on that, it prompts me to create a print layout title. I'll just name the print layout NYC Schools. And so this leads you to the print composer. And so basically there's nothing added to the document yet. I can add everything that's in the map layout. So everything in the data view here, I can add to the print composer using this icon here. It just looks like a roll of paper. And then I draw an outline of where I want to add the map. And so you should be able to see all the data now. That's about the size that we want it, but if it's not really centered where we want it, you can click on this icon here. It looks like a hand, and you can actually move that wherever you want it. And then if you want to move the centering of the data in the map window, you can click on this icon here that says select move item. It's a little pointer tool. And so you can see I'm moving this item around in the map view. And if I want to move the content within that window, I can click on this icon here. It looks like a bunch of arrows over a piece of paper. And that's how you can move the data within that item. And so next, if I want to add a title to the document, I click on this item here to add a text item to the print layout. Just draw where you want your title. You can see as I'm adding items, they're showing up in a list right here. This is the drawing order. And so if this title item is above the map in the drawing order, basically it's going to obfuscate the data in that map window. And so I'll name the document NYC Schools. You can change the font size of that title using the appearance options under the label item properties window. And so if I click on font, it prompts me to click a font size, a font type. I'll just set it to 18. I can center that item using the horizontal alignment option here. And then I can also add legend to my map using this. So you can see this has added all the items in my layers list over here to the legend. And so some of these items are turned off. They're not actually visible in the map window. And so to remove those items from the legend, I can just right click on auto update. And that basically makes it so that these items are not synchronizing to what's in the layers list over here. And so whenever this is clicked, auto update, the items in this legend are going to be synchronized to what is visible in the layers list. And so now that it's not clicked, I can click on some of these items and remove them just using the minus sign at the bottom here. So I'll remove green space, libraries. You can also rename items in the legend by double clicking on them in this list here. So I have private schools. I'm just gonna rename that layer to private schools. And so now that we have all this information here, we can export our map to a image file just using this icon up here. It looks like a image. You can also export your document to a PDF using the PDF icon. I'll just export it here to a PNG file, and I'll name it NYC Schools. And you can pick your resolution. Most people pick 300 dpi, but you can customize that. And you just click save. And now you should get a message that you've exported your layout to an image, and it gives you the directory that the image is in. And if you click on that, it should open the directory. So yeah, I think that's all the time I have. yeah, let me know if you have any questions. Yeah, thank you.
All right. Thank you, Ryan. And next up is our very special guest from New Mexico, and author of many books about QGIS. I'm pleased to present Kurt Menke, who's going to talk a little bit about the QGIS community.
Thanks, Keith. So I know we've had some lag issues. I'm just going to show a PowerPoint, so hopefully this doesn't lag for you. I think one thing that people forget a lot when they first start using QGIS is about the community, and I don't have much time, so I'm going to go through, I won't introduce myself at the moment, but when you first download QGIS and start using it, whether you're aware of it or not, you're joining a community, and I think the community is really what makes QGIS such a special piece of software. So it is both a software and a community. This is a picture from one of the recent, actually the most recently held QGIS conference. They've been, you know, now in the age of COVID, lots of conferences are being canceled, obviously. But this was the user conference in A Coruña, Spain in 2019. So this is a picture of a lot of the QGIS core developers and power users. And so QGIS itself does have a formal organization. It's registered as a nonprofit in Switzerland, and there is an organization behind it. So there's a project steering committee, which basically decides and steers the project in you know, hopefully in a good direction, and operates as a democracy. And I'll get to a little bit of how even people in the US can participate in this in a minute. So QGIS is a very much a team effort, and QGIS is also an open book, like most nonprofits. All the governance docs, budgets, and things like that are available from the QGIS webpage. So you can always go to the webpage, to the Getting Involved section, and look up the governance docs, for example, and the code of conduct and everything else. So I do have a link at the bottom of this slide that would take you to where some of that material can be found. And I think one of the interesting things about working with an open source piece of software is that there's a thinner line between you as a user and the developers of the software. Many of the developers are also users, and users are developers, and you can actually contact those people. So to kind of put some faces to this community, here are some of the people who contribute to QGIS, both in terms of code, but also teaching and mentoring people as well. So it is a community of real people, and they're usually very welcoming to newcomers. And the nice thing is with QGIS, there are listservs, for example. You can go to the QGIS site and sign up to be on the user listserv, for example. And then you can start asking questions. And when you ask a question to the listserv, it's going to be one of these you know, developers or people involved in the project who is going to volunteer their time to help you with whatever your issue you have. So it's a really nice community from that point of view. And I think most people obviously realize that there's code being written, but there's a lot of other ways that people contribute to the QGIS project besides just writing code. For example, holding this, you know, webinar today would be an example of that. So there are people who are creating training materials. I've put some of the less codey ones here in bold. Running user groups. Obviously, financial donations are important. It keeps the project afloat, helps developers squash bugs and things like that. Organizing local events, even helping people out on social media and platforms like that is a big part of how people can contribute. So one of the most obvious ways that people can start is forming QGIS user groups, like I think you have in New York. So there's also a QGIS US organization. And the national QGIS organizations actually get a vote on important matters in front of the QGIS project steering committee. So for example, QGIS US, there's one designated voting member. That's me. And so there is an actual listserv for QGIS US. We are kind of an anemic organization for such a large country, so we're always kind of figuring out ways to get more involved and do more things. We may actually be forming a national QGIS webinar in lieu of having a conference later this summer, so I'll try to keep everyone apprised of that. So this is a map of where all the QGIS national user groups are around the world. So you can see it's very Eurocentric, but we do have an organization here in the United States. And like I said, we have a listserv, but other than that, there's not a lot of activity simply because the few people that are involved haven't had time to do more with it. So if that's something that's of interest to you, you can certainly reach out to me or Keith, and we can point you in a direction to how to get more involved with that. And I think one of the take-home messages around a project like QGIS is that it's a duocracy. This woman here is Anita Graser, who's an Austrian who's heavily involved in QGIS, and she coined this term for QGIS a few years ago. And what this means is that if there's something that you need in QGIS that doesn't exist, you can help fund that feature. What you're looking at in this animation is a feature that myself and a few users helped fund a few years ago that allows QGIS to be able to render categorical rasters, like this vegetation raster here. And so you can always fund or crowdfund new functionality, report bugs so that they get fixed, and really become involved at that level. And it's very empowering. So you can also follow QGIS. There is a Twitter feed for the QGIS project, and Twitter is in general is a great platform for following QGIS news. All the code is on GitHub, so you can always go there, and that's where you actually report bugs that you encounter. And again, that is a very important way to contribute, because if you encounter a bug and don't report it, it may not get fixed. But if you do report it, there's a good chance it gets fixed fairly quickly. So just think about how, in this short introduction, how you can be part of QGIS. And I want to mention, I just added this during this webinar because this just came up recently, but one of the core QGIS developers, Niall Dawson, this afternoon is going to be live showcasing some of the new features in QGIS 3.14, which is going to be called Pi. And he's going to be talking about some of the new functionality for handling temporal data and animating that in QGIS. So if you have time this afternoon, you can go to this YouTube link and watch that. So there's a second webinar today that will be very entertaining and informative. And a shameless plug on my part, I'm the author of a couple QGIS books. So if you're looking for some more resources, Locate Press is a press that was founded by Gary Sherman, who started QGIS back in 2002. And I've published a couple books with his press, Discover QGIS 3X, which is a big workbook for QGIS. And if you're interested in hydrological applications, myself and Hans van der Kwast just published a book last fall on QGIS for hydrological applications. So there's a lot more resources out there these days than there used to be. So thanks. That was just a quick introduction to the community. And I guess now we're going to be opening this up for Q&A, but this is my contact information if you want to reach out and ask me any additional questions going forward.